third type of potential energy is gravitational potential energy. It's very easy to give an object gravitational potential energy. You quite simply lift it up.
Any object that moves upwards gains gravitational potential energy. You can gain it climbing upstairs or standing on top of a mountain. If you really want to gain a lot of gravitational potential energy, you need to go up in a plane. The higher you are off the ground, the more gravitational potential energy you have. Fairground rides are excellent places to gain gravitational potential energy. However, you need to be prepared to lose it quite quickly as well. Now for a quick experiment to show how gravitational potential energy can be changed into other forms of energy. I took some of my lab geeks up to the top of a very high fire escape.
Whoa, look how high it is!
By throwing one over the edge, I could test out my theory.
Wait, come on, over the edge.
I don't want it!
Want to do an experiment? Over, that's it, over. Right, at the moment his gravitational potential energy is stored. That's what potential means. But we're going to get rid of it now by pushing him over the edge. Okay, lads, push him over.
Oi!
Well, there goes that theory. Geeks can't fly. Still, it did show us that the gravitational potential energy had changed into another form of energy. But what type?
I think it changes into sound energy because he screams.
I think that is kinetic energy because he is moving.
I think I need an ambulance!
Which one do you think is the truth?
That's correct. The answer is B.
So, to give something gravitational potential energy, all you've got to do is lift it up. It's stored potential energy. If you want to give it more, you lift it higher. And to get rid of the gravitational potential energy, we release it. It becomes kinetic. Dead easy to remember, isn't it? Right, hold it today, you lot, in your cupboards, come on. Come on, back in your cupboards, back along.
Okay, we're going to go ahead and look at gravitational potential energy. Gravitational potential energy is energy due to an object's position. It's due to the height of an object. Now, when we talk about this, we must define the zero level, because where we place the zero level is going to impact what value we get for the gravitational potential energy. Now, if an object is above the zero level, it's going to have a positive gravitational potential energy. However, if we put the zero level high up, then the height is going to be negative, and there will be a negative gravitational potential energy. If the object is right at the zero level, then it will have zero potential energy. Now, this energy is a scalar, just like the other energies. It does not have a direction that goes with it. However, it can be positive and it can be negative. Okay? Where we place that zero level is going to depend whether or not the value is positive or negative. So if this is the zero level and I go up to here, you might say that I went up to the 5 joules, so it'll have a positive value. Okay? If we say the zero level is right here, then when I go down, I'm going to go down to negative 5 joules. What you'll notice is the same is the change in potential energy. If I start here and this is zero level, and I go down there, I'm going down by 5 joules. Okay? But if I had said this was the zero level, and I went up there, if I'm here again and I go down from this point to that point, I still went down by 5 joules. So despite the fact that the potential energy is a little bit of an arbitrary value, the change in potential energy is not. So potential energy is a scalar, could be positive, could be negative, depending on where we set the zero level. And the potential energy of an object is based on a couple of things. One, the mass of the object, which we need to have measured in kilograms. If it's not, we need to convert it. The gravitational field strength, which on Earth is still 9.81 newtons per kilogram. So an object in outer space or an object on Jupiter is going to have a different potential energy than one on Earth, but we're going to be dealing with objects on Earth, so gravitational field strength 9.81 newtons per kilogram. And the height above or below the zero level, and again we have to define where that zero level is in order to do the problem. The symbol is PEG, which is the gravitational potential energy, and it again is measured in joules. Okay, let's go ahead and try a problem. Problem says, what is the potential energy of a 0.2 kilogram baseball that is at a height of 15 meters in the air? Consider the zero height to be the ground. So, draw our picture. This is the height of 0. This is the ball, and it is 15 meters in the air. So the height is 15 meters up. Okay, got our picture. Write down what we're given. Well, a 0.2 kilogram baseball, that is the mass of the baseball, and it is already in kilograms, so we don't have to worry about converting it. At a height of 15 meters in the air, and the zero height is the ground, so the height is going to be a positive 15 meters. We went up 15 meters from the ground to get there. We do know the gravitational field constant on Earth is 9.81 newtons per kilogram. And now we are ready to write down what we're trying to find. We are trying to find the gravitational potential energy, so PE with a little g. Next step, write down our equation. Well, the gravitational potential energy is equal to the mass of the object multiplied by the gravitational field strength multiplied by the height. So the gravitational potential energy is equal to 0.2 times 9.81 newtons per kilogram times a height of 15 meters. Our gravitational potential energy is going to be equal to 29 and 43 hundredths joules.